Hi, my name is Rizza Lynn and Japole. Today, I am going to give a short information about the three topics that I have chosen in Management Information System. So first topic is Executive Information System. What is Executive Information System? Executive Information System is also known as Executive Support System. It is a type of management information system that facilitates and supports senior executive information and decision-making needs. It provides easy access to internal and external information relevant to organizational goals. Executive information systems are enterprise-wide decision support systems that help top-level executives analyze, compare, and highlight trends, important variables so that they can monitor performance and identify opportunities and problems. So, these are the components of executive information system: hardware, software, user interface, and telecommunication. So, hardware, when talking about hardware for an executive information system environment, we should focus on the hardware that meet the executive's needs. The basic hardware needed for a typical EIS includes four components. Input data entry devices is the first component, which is devices allow the executive to enter, verify, and update data immediately. The second component is the central processing unit, which is the kernel, controls the other computer system components. Number 3 is data storage files. The executive can use this part to save useful business information. Number 4, several EIS products for network workstations became available. These systems require less support and less expensive computer hardware. So the next components of EIS is software. Choosing the appropriate software is vital to design an effective EIS. Therefore, the software components and how to integrate the data into one system are very important. A typical EIS includes four software components. The first software component is text handling software. It is documents that are typically text-based. The second is graphic-based. Graphics that can turn volumes of text and statistics into visual information for executives. Third, typical graphics types are time series charts, scatter diagrams, maps, motion graphics, sequence charts, and comparison-oriented graphs. Fourth component of EIS is model-based. EIS models contain routine and special statistical, financial, and other quantitative analysis. The third one is user interface. An EIS must be efficient to retrieve relevant data for decision makers, so the user interface is very important. Several types of interfaces can be available to the EIS structure, such as scheduled reports, which is using command language, question or answers, which is using natural language, and then menu driven, which is input or output. The last components of EIS is telecommunication. As decentralizing is becoming the current trend in companies, telecommunications will play a pivotal role in network information systems. Transmitting data from one place to another has become crucial for establishing a reliable network. Telecommunications within EIS can accelerate the need for access to distributed data. Applications of EIS. EIS helps executives find those data according to user-defined criteria and promote information-based insight and understanding. Unlike a traditional management information system presentation, EIS can distinguish between vital and seldom used data and track different key critical activities for executives, both which are helpful in evaluating if the company is meeting its corporate objectives. After realizing its advantages, people have applied EIS in many areas, especially in manufacturing, marketing, and finance areas. Samples of EIS is the Sutter Home Winery uses mostly external data, including information from the internet in its EIS. It organized the information in order to help executives make decisions based on trends in the marketplace. The information includes data on competitors and information from market research. Sutter uses its system output to determine sales forecasts, marketing campaigns, and investment plans. Therefore, there are a number of benefits and limitations for us in EIS. However, their value comes not only from their use but also from their development. The process of building and implementing an EIS forces executives and managers to think about the key factors of their business. In addition, an EIS can support both a shared vision of the company and its objectives, the differing visions of its individual executives. In addition, provide a generalized computing and communication environment to senior managers to support strategic decisions. They draw some data from the management information system and allow communication with external sources of information, but unlike decision support system, they are not designed to use analytical models for specific problem solving. Executive information systems have menu-driven, user-friendly interfaces, interactive graphics to help visualization of the situation, and communication capabilities that link the senior executive to the external databases he requires. EIS are designed to facilitate senior managers' access to information quickly and effectively. So let's go to the second topic, which is the decision support system. So what is decision support system? Decision support system are a specific class of computerized information system that supports business and organizational decision-making activities. A properly designed decision support system is an interactive software-based system intended to help decision makers compile useful information from raw data, documents, personal knowledge, and/or business models to identify and solve problems and make decisions. Components of decision support system. There are three fundamental components of decision support system. The first is database management systems, or DBMS. To solve a problem that necessary data may come from internal or external database. In an organization, internal data are generalized by a system such as transaction processing system and management information system. External data came from a variety of sources such as newspapers, online data services, databases like financial, marketing, and human resources. The second is model management system. It stores and accesses models that managers use to make decisions. Such models are used for designing manufacturing facility, analyzing the financial health of an organization, forecasting demand of a product or service, etc. The last one is the support tools. Support tools like online help, pulls down menus, user interfaces, graphical analysis, error correction mechanism facilitates the user interactions with the system. There are also the classification of decision support system. There are several ways to classify decision support system as follows. Number 1 is text-oriented decision support system. It is contain textually represented information that could have a bearing on decision. It allows documents to be electronically created, revised, and viewed as needed. The second one is the database-oriented decision support system. Database plays a major role here. It contains organized and highly structured data. The third one is spreadsheet-oriented decision support system. It contains information in spreadsheets that allows create, view, modify, procedural knowledge, and also instructs the system to execute self-contained instructions. The most popular tool is Excel and Lotus 2-3. The fourth one is solver-oriented decision support system. It is based on a solver, which is an algorithm or procedure written for performing certain calculations and particular program type. The fifth is rules-oriented DSS. It follows certain procedures adapted as rules. The last one is compound DSS. It is built by using 2 or more of the 5 structures explained above. Types of DSS. Status Inquiry System is the first type of DSS. It helps in taking operational management level or middle level management decisions. For example, daily schedules of jobs to machines or machines to operators. The second one is data analysis system. It needs comparative analysis and makes use of formula or an algorithm, for example, cash flow analysis, inventory analysis, etc. The third one is information analysis system. In this system, data is analyzed and the information report is generated. For example, sales analysis, accounts receivable systems, market analysis, etc. The fourth one is accounting system. It keeps track of accounting and finance-related information. For example, final account, accounts receivables, account payables, etc. that keep track of the major aspects of the business. The last one is the model-based system. Simulation models of optimization models used for decision-making are used infrequently and creates general guidelines for operation and management. Examples of DSS. For example, a national online book seller wants to begin selling its products internationally, but first needs to determine if that will be a wise business decision. The vendor can use a DSS to gather information from its own resources, using a tool such as OLAP to determine if the company has the ability or potential ability to expand its business, and also from external resources such as industry data to determine if there is indeed a demand to meet. The DSS will collect and analyze the data and then present it in a way that can be interpreted by human some decision support systems, very close to acting as artificial intelligence agents. Therefore, the conclusion is DSS can be extremely beneficial to any organization's overall performance. However, DSS can also be the cause of great confusion, misperception, and even inaccurate analysis. These systems are not designed to eliminate bad decisions. The DSS are there to facilitate manager in marketing operational decisions, but the ultimate burden of responsibility lies with the manager. Also, if managers continue to ask the wrong questions or queries, the benefit of the systems is already partially lost. A DSS can magnify the harm by justifying the manager's position simply because of the logic of the manager's queries or because the manager draw the wrong conclusion about a certain output. However, DSS remains a tool that can provide firms with a sustainable competitive advantages, and in many industries, a robust DSS are the rule rather than the exception. As technologies evolve, DSS will change and adapt to the challenges of the new economy, and firms should thus continuously be aware of new landscapes that are being formed and streamline their information systems applications with current industry trends and technological advancements. So let's go to the last topic, which is the expert system. What is an expert system? An expert system is an interactive and reliable computer-based decision-making system which uses both facts and heuristics. Heuristics means enabling a person to discover or learn something for themselves to solve complex decision-making problems, which means these systems are designed to solve real problems in a particular subject area, or a computer software that tries to act like human who specializes in a particular domain that normally would require human expert. It is really can solve many types of problems. It is often used to advise non-experts in situations where a human expert is unavailable. This means that these systems are very useful for those people that are lack of knowledge in situations where those experts is unreachable, or it may be too expensive to use a human expert, especially when their locations is difficult to reach. Examples of an expert systems. The first example is MySyn, one of the earliest expert systems based on backward chaining. MySyn was originally developed by Edward Shortleaf for Stanford Medical School in the early and mid-1970s. Written in Lisp, a language or a set of languages actually geared towards artificial intelligence. Mycin was one of the pioneering expert systems and was the first such system implemented for the medical field. It can identify various bacteria that can cause severe infections and can also recommend drugs based on the person's weight. This is a system which diagnoses and treats bacterial infections of the blood. The name comes from the fact that most of the drugs used in the treatment of bacterial infections are called something MYCIN. It is intended to be used by a doctor to produce advice when treating a patient. The idea is that mycin can extend the expertise of the doctor in some specific area. The second example of expert system is dendral, which means the acronym is dendritic algorithm. It was an artificial intelligence-based expert system used for chemical analysis. It is actually developed beginning in 1965 by researcher Edward Feigenbaum and the geneticist Joshua Lederberg, both of Stanford University in California. Heuristic dendral, later shortened to dendral, was a chemical analysis expert system. The substance to be analyzed might, for example, be a complicated compound of carbon, hydrogen, and nitrogen. Starting from spectrographic data obtained from the substance, dendral would hypothesize the substance's molecular structure. Dendral's performance rivaled that of chemists expert at this task, and the program was used in industry and in academia. The next is R1/SCON. The R1, internally called XCON or XCON, which means Expert Configurer program, was a production rule-based system written in OPS 5 by John P. McDermott of CMU in 1978 to assist in the ordering of DEX-VOX computer systems by automatically selecting the computer system components based on the customer's requirements. It could select specific software to generate a computer system wished by the user. PXDES, or which means Pneumocognosis X-ray Diagnosis Expert System. It is an expert system which is used to diagnose lung diseases. It could easily determine the type and the degree of lung cancer in a patient based on the data. The next is CADET, which means cancer detection. CADET is a computer-based clinical decision support system for early cancer detection. Cancer risk evaluation and early detection are subject to serious limitations mainly related to human factors and to characteristics of the data involved. It is a clinical support system that could identify cancer in its early stages in patients. The last one is DX-Plane, designed by the Laboratory of Computer Science at the Massachusetts General Hospital. Work on DX-Plane began in 1984 with the first version being released in 1986. It was a clinical support system that could suggest a variety of diseases based on the findings of the doctor. The system also serves as a clinical reference with a searchable database of diseases and clinical manifestations. Components of an expert system. Knowledge base is the first component. This is all about the collection of facts and rules which is describe all the knowledge about the problem domain. Interference engine, the part of the system that chooses which facts and rules to apply when trying to solve the user's query. The last one is user interface, the part of the system which takes in the user's query in a readable form and passes it to the interference engine, and then displays the rules to the user. And the conclusion is, therefore, I conclude that an expert system is very interesting field of artificial intelligence. As an expert has knowledge that help to advise, same like that expert systems has knowledge base that helps inference engine to advise. In addition, an expert system may result much better than a human expert because it contains several expertise, which implemented correctly, expert systems may remove human error. Also, expert system can be used as a tool for organizing researchers' knowledge. Thank you for listening, and that's all.